students, so today we are going to solve mock test 10. So let's begin with this mock test. Okay, let's start with the first question. What is asked in the first question? In first question, you have to tell that which of the following factor does not contribute to the lower basicity of aromatic amines compared to aliphatic amines. Okay, so 4 things are given to you: resonance stabilization, electron withdrawing effect, steric hindrance, and solvation effect. So you have to tell which does not contribute. So first, if we talk about stabilization, if resonance stabilization effect of amine, so resonance, it decreases the basicity due to the delocalization of nitrogen lone pair. Okay, if we see the resonating structures of the aniline, we can take a aromatic amine like a aniline. So if we draw the resonating structures, so first this nitrogen lone pair will go here. See, I'm drawing the resonating structures. So here I will have double bond NH2. Here I will have a negative charge, and this will go like this. Okay, the next resonating structure which we can draw, this will come here and this will move to this side. So I will have double bond NH2 and of course positive charge over here. Okay, we have a bond over here, we have a negative sign over here, and this. Okay, next if I draw the resonating structure, so this will move here and this will go here. So see, this will be double bond NH2 plus, and this will be here, this bond will be here, and here I will have a negative sign. Okay, and if I draw the last resonating structure, then I will have, this will go here and this will go here. So these are the resonating structures of aniline. Okay, so here you will see that these lone pair of electrons, they are delocalized into the ring. Okay, so this factors contributes. Next, if I talk about electron withdrawing effect, then electron withdrawing group, they pull the electron density away from the nitrogen, and this also decreases the basicity. If I talk about solvation effect, then solvation effect tells us that how the protonated form interact with water. So the factor which least contribute is the steric hindrance one. Okay, so the right answer for this question will be C, that is steric hindrance. Okay, let's move on to the next question. Okay, now moving on to the next question, it is being asked that which reagent confirms the presence of an aldehyde group in glucose? Okay, so 4 reagents are given to you: hydroxylamine, bromine water, acetic anhydride, and nitric acid. So you have to tell that which confirms the presence of an aldehyde group. Okay, first we will see the reaction of glucose with each one of them. Okay, so here if we have a glucose, CHOH4, and here we have CH2OH. Okay, so first if I see it with hydroxylamine, so glucose reacts with hydroxylamine, that is NH2OH. Okay, and it forms an oxime. Okay, that is this OH, CHOH4 and CH2OH. So its reaction with hydroxylamine to form oxime, it confirms the presence of the carbonyl group and not the aldehyde group. That means this option is not right. Okay, now if we see with acetic anhydride, then this glucose reacts with acetic anhydride and see what it forms. This is, okay, let's see if this glucose reacts with acetic anhydride. Okay, so you will see over here C double bond O, CH3 whole 4. Okay, and CH2O, C double bond O, CH3. Okay, so this is the formation of glucose pentaacetate. Okay, so when glucose reacts with acetic anhydride, we form glucose pentaacetate, which confirms the presence of hydroxyl group, which is OH group. Okay, so that means this option is also not right. Okay, so we will see next option. So this is also wrong. Acetic anhydride is also wrong. Now, if we move on and see its reaction with nitric acid. So if this is glucose, it reacts with dilute HNO3. It forms a saccharic acid. Okay, that is CHOH4 and COOH. Okay, so if you will see over here, then what happens? There is oxidation. In this case, there is oxidation of a glucose with a strong oxidizing agent like nitric acid, which forms a saccharic acid. Okay, so this confirms the presence of an alcoholic group, which is CH2OH group. That means this option is also wrong. So we are left with this, which is bromine water. Okay, so if this is glucose, when it reacts with Br2 water, it forms gluconic acid, that is COH, CHOH4, and then we have CH2OH. So this forms gluconic acid. So this glucose, when reacts with mild oxidizing agent like bromine water, it produces gluconic acid, and this indicates the presence of an aldehyde group. Okay, so that means the right answer for this question is which? It is the bromine water. Okay, so option number B is the right answer. Okay, now let's move on to the next question. Next question, it is asking you that the D in D-glucose refers to. So if it is written like this, then what does this D indicates? So if we talk specifically about D configuration, then in D configuration, if the OH group on the chiral carbon furthest from the aldehyde or ketone group is on the right side of the Fischer projection. Okay, so if I take example of a glyceraldehyde, then this is CHO, this is CH2OH, this is H, and this is OH. So you will see that this OH is on right side. Okay, this OH is on which side? Right side. Okay, so this indicates that if this OH on the chiral carbon is on the right side, then this shows it is a D configuration. Okay, so you can write it as plus glyceraldehyde. Okay, and what does this plus over here stands for? This plus over here stands that it rotates the plane polarized light into right direction. So it is dextrorotatory. Okay, this is dextrorotatory. Alright, so if I talk about this D in the glucose, what does this tells us? This tells us about the configuration relative to the D-glyceraldehyde. Okay, this plus tells us about the dextrorotatory nature. So this is wrong. The presence of 5-hydroxyl group, this is also wrong, and this is also wrong. Okay, so if it is asked about D, then D means it is configuration relative to D-glyceraldehyde. And if this about plus was asked, then this plus is that it is dextrorotatory in nature. Okay, so the right answer for this question is B option. Okay, let's move on to the next question. Now, next question is asking which statement about the reducing sugar is correct. Now, if we talk about the reducing sugar, then if I talk about monosaccharides, okay, I'm talking about monosaccharides, then all the monosaccharides, both aldose, both aldose and ketose. So if I talk about monosaccharide, both aldose and ketose, then all monosaccharides are reducing sugar. Okay, and one more very important property, that they reduce Fehling solution and Tollens reagent. Okay, so the right answer will be all monosaccharides are reducing sugar. Okay, and if we talk about disaccharide, so a disaccharide is a reducing if it has a free hemiacetal or a hemiketal group on the anomeric carbon. Okay, so if it has a free hemiacetal or hemiketal group, then it is a reducing sugar. Okay, so if you see, all polysaccharides are reducing sugar. Most of the polysaccharides, they are non-reducing sugar. And if I talk about sucrose, then sucrose is also a non-reducing sugar. Okay, so the right answer for this question is A, that is all monosaccharides are reducing sugar. Okay, now let us see the next question. Moving on to question number 5, it is asked, which of the following carbohydrate is a polysaccharide? Okay, so first of all, what is a polysaccharide? So polysaccharide yields large number of monosaccharides. Okay, so they yield large number of monosaccharides unit on hydrolysis. Okay, and they are also non-sugars. Okay, so if it is asked about polysaccharides, and examples of polysaccharides are starch, cellulose, or even glycogen. So if you look over here, then what is the right answer? Cellulose is the right answer in this option. Okay, if I talk about glucose, glucose is a monosaccharide. Okay, and sucrose and maltose, they are disaccharide. So the correct option is cellulose, which is D1. Okay, now let's move on to the next question. Now next question, it is asked that on hydrolysis sucrose produces. So first of all, if we talk about sucrose, so sucrose is a disaccharide. Okay, it is a disaccharide. So that means it will yield 2 units of monosaccharides. Okay, it will yield 2 units of monosaccharides. So if I talk about sucrose, the molecular formula, it is C12H22O11. Okay, when we react it with water in the presence of an acid, it yields 1 molecule of glucose, which is C6H12O6, and another molecule of fructose. Okay, so both are, this is in aqueous and this is also in aqueous, and this is in solid. Okay, so that means on hydrolysis sucrose produces 1 molecule of glucose and 1 molecule of fructose. So the right answer will be option number B. Okay, now let us move on to the next question. Now next question, it is asking, what is the purpose of acylation in aromatic amines? Okay, so if I take an example over here, then look at this example. By this it will be cleared what is the purpose. So here if I have this molecule and I react it with acetic anhydride, okay, O double bond O CH3. So what this will do, so you will see in this case NH double bond O CH3, and we will get. So now what is happening, if I am doing the acylation, then this acylation, it converts this NH2 group into this group, which is NHCOR group. Okay, so if I talk about this group is less activating, as lone pair in the nitrogen are less available for resonance with the ring. Okay, so this acylation, it protects the amino group from oxidation, and it also reduces the ring reactivity. So if you see the options, increases basicity is wrong, protects the amino group, yes, deactivate the ring, yes. So that means both B and C, they are right answer for this question. Okay, that means it serves both the purpose, protect the amino group and also deactivate the ring. Okay, so that means D is the right answer for this question. Now let us see the next question. Next question is saying that which of the following statement about amines is correct? So it is asking the correct statement. Okay, so if it is saying, it is written alkyl amines are weaker bases than ammonia, alkyl amines are stronger bases than ammonia, aniline is stronger base than ammonia. Okay, first if I talk about alkyl amines and ammonia, okay, first we will compare alkyl amines versus ammonia. Now let us see among them. So what happens if I talk about them, then the electron releasing nature, that is the plus I of the alkyl group, they pushes the electron density towards nitrogen. So that means electron pair of nitrogen, they are more available for sharing with the proton of the acid. Okay, so suppose if here I have alkyl amine, okay, and this H plus over said H plus, okay. So if I look at this protonated form, so this is about the alkyl amines. Now if I look towards the ammonia, so see in the case of ammonia, if you see in the case of in the case of an alkyl amine, here I have R group. Okay, so this has a plus I effect. So this plus I effect, they pushes the electron density towards the nitrogen. Okay, and if you will see the substituted ammonium ion formed from the alkyl amines, they are more stable than ammonia. So if I talk about this, these are more stable compared to this one. Okay, this is because of the dispersal of the positive charge by plus I effect of this alkyl group. Okay, so if I talk about alkyl amine versus ammonia, then I can say alkyl amines, they are stronger bases than ammonia. Okay, now if you also want to compare between the aryl amine versus ammonia, okay, this was alkyl amine versus ammonia. Now if we see about aryl amine versus ammonia, then if I talk about, then the aryl amines, they are significantly weaker bases than ammonia. Okay, but this is because of the two factors. First is because of the resonance. Second one is because of the stability of anilinium ion. Okay, so if I talk about resonance, then I already drawn the resonating structures of the aniline, okay, which is NH2. So if you will see that the lone pair which is present on this nitrogen, it is delocalized into the benzene ring, which makes it less available for protonation. Okay, so if you will see, this has 5 resonating structures. Okay, next if I talk about the stability of anilinium ion. So if this is aniline C6H5NH2, when it accepts a proton, that is H plus, it gives us anilinium ion, that is C6H5NH3 plus. This is anilinium ion. And if you look at the resonating structures of the anilinium ion, this is NH3 plus. So they have only 2 resonating structures. One is this and another one is this. Okay, so anilinium ion has only 2 resonating structures, whereas aniline, it has 5 resonating structures. So greater the number of resonating structures, greater is the stability. So aniline is more stable than the anilinium ion. Okay, because aniline has 5 resonating structures, they have 2. So therefore, if I compare ammonia, so ammonia is more basic than aryl amines. Okay, so if you will see, aniline is stronger base than ammonia, this is wrong. Aryl amines, they are weaker base than ammonia, this is also wrong. Correct is alkyl amines, they are stronger base than ammonia. Okay, so the correct answer for this is D1, that alkyl amines, they are stronger base. Okay, now let's move on to the next question. Now next question, it is saying that what is the product when aniline reacts with excess of bromine water? Then if I talk, this is an electrophilic substitution reaction. Okay, so if this is an aniline over here, this is aniline, then the NH2 group, this group, it activates the ring leading to the bromination at ortho and para positions. Now what happens in this reaction? If you treat it with bromine water, it forms a polysubstituted product. Okay, so here you will see that the bromine gets attached to ortho and para position. If this is one 2, 3, 4, 5, 6. Then you will get 2, 4, 6 tribromoaniline. Okay, this is the product which you get. Okay, so this Br groups come and attaches at second, fourth and sixth position. So 2, 4, 6 tribromoaniline. This is because of the highly activating nature of this NH2 group. Okay, so the correct option will be 2, 4, 6 tribromoaniline. Okay, so this tri over indicates that 3 bromine groups are there. So this is the correct answer. Now let us move on to the next question. The next question, it is saying which reagent is used to distinguish between primary, secondary and tertiary amines. Okay. Now if you'll see at this question, then if I talk about Heisenberg's reagent, they react differently with primary, secondary and tertiary amines. Okay. So one by one we will see its reaction. First we will see it with primary amine. Okay. So when I talk about primary amines, then if this is benzene sulfonyl chloride, let me draw it again. Yeah. Okay, so this is a benzene sulfonyl chloride. We have S double bond O Cl. So this is a benzene sulfonyl chloride when it reacts with a primary amine. So in primary amine, nitrogen is bonded to 2 hydrogen and 1 alkyl or aryl group. Okay. So what does this form in this case? If you will look, S double bond O HR plus HCl. So this forms N-alkyl benzene sulfonamide. Okay, so this forms N-alkyl benzene sulfonamide. So this is when benzene sulfonyl chloride reacts with a primary amine. Okay, and if I talk about this N-alkyl benzene sulfonamide, then this is soluble in alkali like NaOH or KOH. This is because of the acidic nitrogen, which is acidic hydrogen. About this hydrogen we are talking. Okay, this is because of this acidic hydrogen which is attached to nitrogen. Okay, so this is when it reacts with a primary amine. And now when this benzene sulfonyl chloride, it reacts with a secondary amine. So if this reacts with a secondary amine like HNR2, then in this case it forms N, dialkyl benzene sulfonamide. Okay, so this forms C6H5SO2NR2 plus HCl. So this forms N, dialkyl benzene sulfonamide. Okay, so if I talk about this one, then this is insoluble. Can you guess the reason? Because if you will see over here, this nitrogen does not have any acidic hydrogen. So it is insoluble. And if I talk about benzene sulfonyl chloride, then they do not react with tertiary amine. If I see reaction with tertiary amine, then they do not react with tertiary amine because there is no hydrogen which is present in this amine. Okay, so Heisenberg's reagent, it is used to distinguish between primary, secondary and tertiary amine. So this is what it forms with different amines. So right answer for this question is Heisenberg reagent. Okay. Now let us solve the next question. Now next question, it is asking that which of the following compounds has the highest boiling point? Look over here what you have given. This is also an amine, this is also an amine, this is also an amine, but this is an alcohol. If you see, this is a primary amine because nitrogen is bonded to 2 hydrogen and 1 this group. This is a secondary amine. This is a tertiary amine, but this is an alcohol. So if we compare alcohol versus amine, then which has the highest boiling point? Then alcohols, they form the stronger hydrogen bonds due to the higher electronegativity of oxygen compared to nitrogen. So the electronegativity of oxygen is 3.5 and of nitrogen it is 3. So if you will see, oxygen which is present in alcohol has more electronegativity, so they form stronger hydrogen bonds. That is why alcohol, they have the higher boiling points compared to your amines. Okay, so for this the right answer will be this. And if I compare primary, secondary and tertiary amine, then in primary amine you have two hydrogens which are available for hydrogen bonding. Here you have only one, and here you have no hydrogen which is available for hydrogen bonding. Okay, so for this the right answer will be alcohol, which is NC4H9OH. Okay, so this is the right answer. Now let us see the next question. Next question, it is saying aniline undergoes bromination to form. Right now only we discuss this question. If I have aniline, which is NH2, when it reacts with 3Br2 in presence of Br2H2O, then it forms a polysubstituted product. Okay, so I have aniline over here. This is NH2. And this Br gets attached to 2, 4, 6 position. Okay, so this forms a white precipitate of 2, 4, 6 tribromoaniline. This is because of the high reactivity of this NH2 group, polysubstituted product is obtained. So the right answer for this is C, which is 2, 4, 6 tribromoaniline. Okay, let us move on to the next question. Which reaction is used to distinguish primary, secondary and tertiary amines? Okay, so right now we only discussed it is this reaction with Heisenberg's reagent. So this is used to distinguish primary, secondary and tertiary amines. So right now we only discussed about this question. So option number B is the right answer. Okay, now let us move on to the next question. It is asking us that which product of the Hofmann bromamide degradation of, what is the product of Hofmann bromamide degradation of benzamide? So see, what is benzamide? This is C6H5 double bondo NH2. This is benzamide. Okay, when you react it, what will be the product of the Hofmann bromamide degradation? Okay, so if in case if you react it with Br2 plus 4 NaOH, then this gives us an aniline, that is NH2, and it gives us Na2CO3 plus 2 NaBr plus 2H2O. Okay, so this is the product in which we get aniline. So the correct answer for this question will be option number B, which is aniline. So this is the product of Hofmann bromamide degradation. If you look over here and you look over here, here we have one carbon less. Okay, so this is the product. So correct answer will be aniline. Now let us see the next question. Next question, it is saying which of the following halides reacts most readily during ammonolysis? So we have RCl, RBr, Ri and Rf. So if I talk about the order of bond strength of halides, I am talking about bond strength of halides. Then bond strength order is, first is R, then we have RBr, then we have RCl. This is bond strength of halide. The bond strength between R and Cl is most and least is between Ri. So if we talk about the order of reactivity of halides in ammonolysis. So now if we see the order of reactivity, then order of reactivity will be just opposite of this. Ri will be most reactive, followed by RBr and followed by RCl. Okay, this is because of the ease of breaking the carbon halogen bond. We can easily break the R and I bond because you will see this bond strength is least because iodine size is very much bigger. So you will see this bond is quite weak, which we can easily break this bond. And if I talk about RF, then RF does not undergo ammonolysis as their bond strength is very high. Okay, their bond strength is quite high, so they do not undergo ammonolysis. Okay, so the right answer for this question will be, which reacts more readily, will be Ri. Okay, so the right answer for this question will be option number C. Okay, now let us move on to the next question. Next question, it is saying that which is the preferred method for the reduction of nitro compounds to amines to minimize the use of hydrochloric acid. Now this method is also an industrial preference. Okay, So if I talk about reduction of nitro compounds to amine, we will see reduction of nitro compounds to amines. Okay, what we are going to use? We are going to use iron scrap and HCl. Okay, so if you'll see, we are going to do with iron scrap and HCl. So if I have iron plus 2 HCl, this is iron and this is hydrochloric acid, it gives us FeCl2 plus H2. Okay, so this is iron 2 chloride. Iron 2 chloride. Okay, and if we have a nitro compound which is RNO2, which reacts with 3H2 in presence of FeHCl, then here we get RNH2, which is an amine, plus 2H2O. Okay, so if I look at a particular example, here if you have a nitro compound, when you treat it with Sn plus HCl or with Fe plus HCl, it gives an amine, which is NH2. Okay, so this is the preferred industrial method, as a small amount of HCl acid is required initially. Okay, so as the FeCl2 formed gets hydrolyzed to release HCl acid during the reaction. So as FeCl2 formed, they gets hydrolyzed to release the HCl. If you see the reaction, then FeCl2, which is solid, plus 2H2O, which is liquid, it gives FeOH2, which is solid, plus 2HCl. Okay, so this get hydrolyzed to release HCl during the reaction. So this is the preferred industrial method, and this is the preferred method to minimize the use of hydrochloric acid. So the right answer for this question will be C, reduction with iron scrap and HCl. Okay, now let us move on to the next question. Which method is preferred? Okay, we have already done this. Next question. Yeah, question number 17. Which method is preferred? What product is formed when this reacts with HCl? Okay, so in this question we will see that this acts like a base. Okay, when it reacts with HCl, then you will see this will donate its lone pair and you will get CH3, CH2, CH2, NH3 plus Cl minus. So we get N-propyl ammonium chloride. This is N-propyl ammonium chloride. Okay, so in this, the right answer for this question will be, for question number 17, it will be A1. That is N-propyl ammonium chloride. So when primary amine, this is a primary amine, when it reacts with HCl, it gives us ammonium salts. Okay, so the right answer for 17th is A1. Now let us move on to the next question. Now next question, it is saying that which factor primarily contributes to lower solubility of higher amines in water? Okay, so if I talk about this, then we will say that as the molar mass of amine increases, the hydrophobic alkyl part becomes larger. Okay, which reduces the solubility in water. Okay, so if you will see, the right answer for this question will be increased hydrophobic alkyl chain, because this is hydrophobic. Hydrophobic is water repelling. So this factor primarily contributes to the lower solubility. Okay, so the right answer will be option number B, which is increased hydrophobic alkyl chain size. Now if we move on to the next question, question number 19. In question number 19, it is asked, tertiary amines have lower boiling points than primary amines. Why? So if we compare tertiary amines and primary amines, which one has the lower boiling point? Because if you will see, the right answer for this question will be, because if I talk about tertiary amines, see, this is a tertiary amine, this is an amine, and here we have 3 alkyl groups. There is no hydrogen which is available for bonding. And if I see secondary amines, then in secondary amines, we have 1 hydrogen which is available for hydrogen bonding. And if I talk about primary amines, in primary amines, I have two hydrogens which are available for the hydrogen bonding. Okay, so if you read this question carefully now, then you will see that tertiary amine lack the hydrogen atoms for intermolecular hydrogen bonding. That is why they have lower boiling points than primary amines. See, there is no hydrogen which is available. Here there is only one, and in primary amine I have two hydrogens. The right answer for this question is they lack hydrogen atoms for intermolecular hydrogen bonding. Okay. Now let us look at the last question. It is saying that among isomeric amines, the correct order of boiling point. So it is asking what is the correct order of the boiling point. So right now only we discussed what is the correct order: primary, secondary, and then tertiary. Okay, if I once again see, this is a primary amine where nitrogen has two hydrogen. So see, this hydrogen can also form hydrogen bonding, and this hydrogen can also form hydrogen bonding. Here we have two hydrogens available. This is a primary amine. Now if I talk about secondary amine, then in case of secondary amine, here this nitrogen only has one hydrogen which is available for hydrogen bonding. This dotted line represents hydrogen bonding. So there is only one hydrogen. And if I talk about tertiary amines, in tertiary amines you will see there is no hydrogen which is available for this nitrogen to do the hydrogen bonding. So that is the correct order for this boiling point is primary, secondary, and then tertiary. Okay, so the right answer for this question will be A, which is primary, secondary, and tertiary. Okay, so with this we end our mock. I hope the questions which we discussed are clear to you. Thank you so much, students.